Okay, so the next thing we're going to talk about is horizontal and vertical lines. So the equation of a horizontal line is y equals. So it starts with y equals. The slope, which we're going to talk about more in the next part, is 0, which means that the line is not going to be slanted up or down. It's just going to be a horizontal line, which goes from left to right. So if we graph an equation like y equals -3, what you do is you go down to -3 on your y-axis. We know this is the y-axis. You go to -3 on it. You can make a point there. And then y equals -3 means that it's always -3 for y, meaning that no matter what, y equals -3 is always going to be the answer. This is a horizontal line at -3. When you're graphing an equation that says just y equals -3, it looks like this. It's a horizontal line at -3 on the y-axis. The opposite of that is when you're graphing something that says like x equals -3. A vertical line starts with x equals. When you go to graph this one, you would now look for the x-axis and go to -3 on the x-axis. This is saying no matter what, x is always equal to -3. Well, all the points on this line always have -3 as the x-coordinate of the point, which would make a vertical line at -3. X equals -3 means no matter what, -3 is always x, and all of the points that have -3 as x look like this. This says no matter what, all of the points have -3 for y. Well, all of these points here have -3 for y, which is why it creates that type of line there. So below, we have two U-try problems. Please pause the video, graph A and B, and then press play when you're ready to look at the answers. All right, let's go over the answers. So for graph A, y equals 5 means go to the y-axis and plot a point at 5. Well, y equals 5 means that no matter what, we want 5 to be the y-coordinate of our graph. All of these points here, this is 1, 5, 2, 5, 3, 5, 4, 5, -1, 5, and so on. All of these points have 5 as its y-coordinate, which creates this horizontal line like that. So y equals 5 looks like that horizontal line. You don't need all of those points. I'm just showing you what it would look like. And then x equals 5 means go to the x-axis, plot a point at 5. No matter what the y-coordinate, x is always going to equal 5. Well, this point here is 5, 1. This point here is 5, 2, 5, 3. This is 5, -1, 5, -2, and so on. All the points on this vertical line have 5 for x, which is what this equation looks like. And moving on to the next part, slope. So now that it's winter and we're probably awaiting a winter storm, you might be watching this right now and maybe there's snow outside, maybe it's supposed to snow, but we are talking about slope now, and slope has to do with real life. If you've ever gone skiing, and they call it the bunny slope. Bunny slopes are easier. They're the kind of slopes I like to go on. I don't like black diamonds or anything crazy like that because bunny slopes are not as steep. The steeper the slope, the faster you go and you go skiing, and I'm not a great skier, so I would prefer to be on like a bunny slope rather than something crazy. So slopes are how steep lines are. And what we're going to do now is look at how we find the slope, how we find the steepness of a line. So slope is the measure of the steepness of a line, and it is described as a constant rate. Now, I know when you're in real life and you're on the bunny slope or a black diamond, the rates of change for those might change a little bit because there might be like a steeper part of the hill or the mountain and then a not as steep part. But when we have a slope of a straight line, they're always constant. So if this is an example of like a graph, our 4 quadrants, and this is the line we have, the line always has the same steepness, which is why it creates that straight line there. Slope is a ratio that compares the change in the vertical distance to the change in the horizontal distance. When you're given 2 points, every point has an x and a y. So if you're given 2 points, this is the first x and this is the first y, which is what these little subscripts 1s are. It's just saying the first x and the first y. And this is the second x and the second y. You can calculate the slope with this formula. This formula looks very crazy. It probably looks like it's in a different language right now, but I promise you once we get to it and we look at how to find them, it'll be a lot easier. What I really want to talk about right now is the 4 different types of slopes. So there's 4 types of slopes we have with lines. We kind of already talked about and looked at equations with these 2, but here are 2 that we haven't really talked about that much. Positive slope. So when you have a line that looks like this line that starts down here and then when you read it from left to right, it's going up, it has a positive slope. That means that the slope would be a positive number because the line is increasing from left to right. Now, I know that this arrow is pointing down here, which is like kind of pointing to the negative numbers, but we read graphs the same way we would read anything from left to right. So because the line is rising and it's going up, this is considered a positive slope. A negative slope is when you read it from left to right and the line is falling down. So it goes down from left to right. That would be a negative slope, and negative slopes are negative numbers. So positive slopes are positive numbers. An example of a positive slope could be like 1/2. If I said the slope of the line is 1/2, that is a positive number, so that would be a positive slope. Or maybe I said the slope is 2. 2 is a positive number, so that would be a positive slope. A negative slope would be a negative number. For example, if I told you the slope of the line was -2/3, that is a negative number, that's a negative slope. I know that line decreases from left to right. Or maybe it was just like -4. That is a negative number, that's a negative slope. The next 2 slopes are a little bit different because this slope is a slope of 0. A lot of times students think that this has no slope, but no slope doesn't really exist. It would be called a slope of 0 or 0 slope because this means that the line is flat. When you're walking around Pencrest, for the most part, unless you're on like maybe the catwalk or something, the ground is flat. The slope of all of the hallways, for the most part, are 0 because you're walking on flat ground. Horizontal lines have a slope of 0 because there is no increase. There is no rate of change. It's always just the same. You're just walking on flat ground. However, undefined slopes, which looks like this, these are vertical lines, and vertical lines are called undefined slopes because once we look at how to find them, when you find these slopes, what happens is the denominator for your slope, the ratio comparing your change vertically to horizontally, the denominator is 0. And because you can never divide by 0, we actually can't define the slope. This slope is so steep that we can't define it. Like even the steepest mountain there is in the world, I don't even know, but maybe there are some snowboarders or skiers that know, the steepest mountain in the world that is maybe the most dangerous to go skiing or snowboarding on, even that doesn't have an undefined slope. Undefined slopes are impossible. Like even like King to Ka, which is like one of the craziest roller coasters with the craziest drop, doesn't have an undefined slope. Undefined slopes are honestly like you can't define them because the slopes are so high, so you can't actually define this as a number. So the next part of this is asking us to graph these points. If you want to follow along in your packet, to graph these points, -1, -2, I know and remember how to graph on the x and y axis from starting at the point here, -1 on x and -2 on y. So I'm going to go to the left 1 and down 2. That's going to be the first point. And then I'm going to go 0, -1, which means start here at 0 on my x-axis and then go down to -1. And then 1, 0, over 1, and you stay here at 0. So these 3 points are actually on the same exact line. So if I was to graph this line, I could connect these points, and I could find another point on this line. Now these 3 points, if I just connected these 3, that's what it would look like. But these 3 points create a line that goes on which we will eventually be finding equations to these lines. And these 3 points have a certain type of steepness. They have a certain slope. This is asking us to find another point on this line that contains these points. So any point that's on this line, now your line has to be accurate enough, but this point here, another point that's on this line is 1, 1, but that's not the only answer. The next point that is on this line would be 3, 2, and we could keep going on forever. Any point that is on that line will be a part of this line, but your line has to be accurate. Mine is not very accurate. I just drew a sketch. Usually in this section, in a traditional setting, I would give everyone a ruler or a straight edge, and you would make a perfect line for this. So if we look here at letter B, it says as x blank, y blank, therefore the slope of this line is blank. Looking at this line, it is going up from left to right. So if we were thinking about walking up this line, you would literally be walking uphill. That means it is a positive slope. So I know that this is a positive slope. And positive slopes happen when x increases and y increases. It's asking us then to identify the change in y and the change in x. So this is what slope is all about. It's about the change in your y versus your change in x. So if we're looking at this graph, I'm going to have to kind of scroll down here and start over. Looking at this graph, if I plotted these 3 points again, -1, 2, -1, -2, 0, -1, and 1, 0, and I connected this line, and this line's perfect, let's say. Looking at this change, let's just look from here to here, from this first point to the second point. If you're looking at the steepness is how far it goes up versus how far it goes over. So looking at this, that will help us determine the slope. To get from one point to the next point, do you see how you can start here at this green point? You have to go up 1 unit to get to the same level as the blue point, and then you have to go over 1 unit to get to this next point. Slope does 2 directions. It tells you how much to go up and how much to go over, or how much to go down and how much to go over. And that's what slope represents. Slope is actually going to be a fraction, and we can find slope using this crazy formula that looks crazy to you right now. But this is going to be something that we're going to do once we get back into the classroom. So what we're going to do now is an activity that's going to be about the types of slope, positive, negative, 0, and undefined slope. And then hopefully we'll be back in the classroom so that we can do the rest of this together live as a group.